But you're missing the point. You're missing the point. So in the wild, okay, because I've got a paper here that I can screen share where nearly all mammals have a similar mutation rate. Okay, so every mammal, including humans, are accumulating more and more mutations. For example, David, you and I, we have 100 more mutations than our parents. We have 200 more mutations than our grandparents, and so on and so forth. So here's the thing: over time, we are accumulating more and more mutations. And even if we've got 8 billion people on the planet, let's just say you were to wipe out, okay, 4 billion of the worst mutants. Now we're all multiply mutant. And remember, selection acts on phenotype, not genotype. So get rid of the 50% of the worst. Well, now you're still left with 4 billion people who are more mutant than the generations prior. Do you see how consistently we are more and more mutant, regardless of how much selection you invoke? Now, here's the thing. You can't invoke too much selection, because if you remove 80% of the population, now you've got a population that's so small that mutations and genetic decline will occur too quickly. So how do you solve that problem? The fact that no matter what you do, no matter how much purifying selection you apply to a population, we are getting worse and worse over time. How do you answer that?
Let me interrupt a second before David says his next bit. Just to remind you, we have 7 minutes left. Go ahead.
Okay, sure. So I guess I'm going to try and get in as many questions, kind of go back with the issues of whole with genetic entropy and all that.
Are you gonna answer that question though, and then I'll let you ask a question.
And so I'll go with the issue of genetic entropy real quick. The point I was trying to make with bacteria, viruses, and other organisms is that even if we cannot apply the same thing mathematically, we should still be seeing them accumulating harmful mutations. One of the big things, of course, coronavirus, and we see headlines of this rapidly mutating, is, of course, the first thing we see as we are afraid. We see, okay, this virus is rapidly mutating. That should be a good thing under the genetic entropy model, because if that means harmful mutations are still going to be accumulating, and therefore there's still going to be an overall rapid decline. The fact of the matter is,
the best thing that could happen to it would mutate to oblivion. That would be the best thing that happened.
Exactly.
We've seen it.
I'm trying to make
yeah, but here's the thing. We've literally seen it with the H1N1 human version, okay, that virus. It went from a red hot pandemic to a whimper to an extinction event in 90 years. This is published in a mainstream journal where it was observed that there was an accumulation, a linear accumulation of mutations where codon bias declined consistently over time. That's not consistent with adaptive evolution that some people have tried to look to. Yeah, now that, there's been some critics, of course, criticizing that paper. But here's the thing. This is a paper published in a mainstream journal. So if you got a problem with it, then go write up your critique or go point out the problems with it and get it published. And you want to talk about bacteria. What's funny is genetic entropy has never predicted that bacteria would go extinct first. But guess what? Are you familiar with Lenski's experiment? Are you familiar with... Oh, go ahead, David. Go ahead.
Genetic entropy is that genetic entropy has never been observed, and the thing of it is,
I just gave you a case in viruses that has been observed.
The thing is, even if we say that bacteria and viruses not predicted to go extinct first, okay, fine. The point that I'm trying to make is that they should still be accumulating harmful mutations, and that they should still.
David, you just dodged everything that I said about the H1N1 human version. How do you explain the fact that it's been published in a mainstream journal, okay, that there was a linear accumulation of mutations that took this H1N1 human version, this virus, it took it from a red hot pandemic to a whimper to an extinction event in 90 years observed in viruses? How do you explain the codon bias, the fact that it declined consistently over time? How do you explain that according to your model?
Again, one of the big things being the vaccinations that we had. But the thing is here...
what are you talking about, David? You're tap dancing all over the place. Answer the question that I just provided you about the H1N1, the human version that went extinct due to genetic entropy. That's not evidence for you? You just said it doesn't happen in viruses. And I'm saying that, yeah, okay, with the new virus that we have, the best thing that could happen to it is that it would mutate to oblivion. So how do you... listen, I gotta hold you to the fire. How do you answer the fact that codon bias declined consistently over time, showing that the H1N1, the human version that is, went extinct due to genetic entropy?
Okay, sure.
Answer that question. Just stick on that question.
Okay, sure. So I'll just respond real quick, quoting here from Dr. Dan. So the whole point of the paper was that the H1N1 fitness declined over time due to genetic entropy. Fitness for the viral genotypes in question was not directly measured. Correlates of the fitness were not directly measured. Fitness was evaluated based solely on two extremely poor proxies. Codon correlates with host and virulence. We can relegate
Okay, David, I'm not just going to let you read word for word what Dan said. I want you to critically think. Okay, here's the fact. The virus started off more human in its codon usage, David, okay? And what it ended up, do you know? Because you're just going to quote Dan blindly. Tell me, the virus started off more human in its codon usage. How did it end up?
Not sure.
It ended up more randomized. So read the paper with an open mind, okay? It became worse, David, at interacting with human DNA over time. And if it is using the wrong codons, that means it will be less efficient at replicating in human hosts. Okay, this is a decline in functionality and matches exactly with genetic entropy. Don't quote, you could quote Dan, but I don't want you just reading some massive paragraph without even understanding it and addressing the key issue. So what I just said, answer that question. Give me an answer from the brain of David. If you don't have an answer, then just say you don't have an answer and we can reconvene.
Okay. Well, again, codons simply do not interact with human DNA. As Dr. Gian just pointed out properly, codons don't interact with human DNA. But that being point, how much time is there left for this?
2 minutes.
How many?
2 minutes. We could go 5 if you guys want.
Sure. So
maybe give another 10. Wait, because I want to leave no stone unturned. And then I know you had a question about the interbreeding, the hypermutation. I do want to answer all your questions. But one thing that's hanging is bacteria. So how do you explain the fact that in the Lenski experiment, what we've observed is just that? Reductive evolution. Lenski's own data has revealed clear evidence of genetic degeneration. His populations of E. coli bacteria, they have shrunk in functional genome size. They have painted themselves into a corner. So how do you explain that?
Incorrect.
No, that is okay. But then give a rebuttal. Why is that incorrect?
No, again, I kind of want to. How is that genetic entropy from your point,
David? Reductive evolution. Okay, the fact that these beneficial mutations, okay, observed in Lenski's experiment, the fact that what we've observed is loss of function, loss of promoter, loss of genes, loss. What they've done is they've gotten rid of genes short term, but it's long-term degeneration, okay? It's like if I was driving a car and temporarily I wanted better gas mileage, so I wanted to remove weight off the car. So I decided to remove the doors, remove the side mirrors, remove some of the seats. Yeah, temporarily I'm going to get better gas mileage because the car weighs less. But guess what? It's not improving the car, nor is it explaining how the car was built. That's exactly what we're seeing in Lenski's experiment. We're seeing reductive evolution. Genes are being lost short term. It's long-term degeneration. How do you explain that?
Okay, but again, that's not what the data actually found. But I think the important thing to remember is that yes, and microorganisms.
Wait, are you denying? I've got the paper pulled up here. Are you denying the fact that Lenski's bacterial populations have shrunk in functional genome size? Are you denying that? I want you to go on record and say you deny that.
What paper are you citing?
Have you read any of Lenski's papers?
No, I have not.
Okay, well, then there you go. Go read his paper. There's a new one in 2020. Okay, that's showing that there's been no forward evolution. You are making a claim that this is wrong. You are making a claim that Lenski's own data has not revealed clear evidence of genetic degeneration with no argument. You haven't given an argument to the H1N1 virus. You haven't provided us a type of mechanism that can remove all these deleterious mutations. I have answered your question sufficiently when it comes to the biodiversity of Neanderthals, the fact that they're a branch of an early man. You